Good afternoon. Buenas tardes. God, it's escorcho, like proper, humid, wet, close. Escorcho. But it's still a glorious day, isn't it? Every day's a glorious day. Right, somebody brought up the UY Scuti. Can you explain the UY Scuti situation? It's exactly the same as with our sun. Talking about the speed of light, remember? So, with our sun, I don't mind calling it our every now and again, but it was obviously my sun. With a diameter of 1,390,000 kilometers, the numbers that they give us, if we divide sun's diameter by the speed of light, 4.6 seconds is what we get. And that 4.6 seconds is how long it would take 4.6 seconds to radiate its light the distance of its own diameter. Now, it's crazy in a world where common sense reigned. That wouldn't pass. Of course it wouldn't. Never. It's illogical. A light source taking 4.6 seconds to radiate its own light, the distance of its own diameter. That's nothing. Now we go over to UY Scuti, which is why it sounds so crazy. But this time, I've gone the extra step. So I've added something to the end of this. Now, UY Scuti with an approximate diameter of 2,377,000,000 kilometers, when we divide its diameter by the speed of light, we get the number 7,920. When we divided the sun's diameter, it was 4.6 seconds. We divide Scuti's diameter by the speed of light, we get 7,920 seconds. We then divide that number by 60, and we get 132 minutes, which means 2 hours and 12 minutes for UY Scuti. So when I stay here and do the sun one, it's in real time. 3, 2, 1, go. 1, 2, 3, 4. 0.6 seconds. Real time. If I did it with UY Scuti and did it in real time, for me to get from, let's say, here to there, with UY Scuti's light, if I did it at the same rate as UY Scuti does it, if you were looking at it from a distance, I would be here for 2 hours and 12 minutes. 3, 2, 1, go. That right there is probably too fast. It is. This is what it would be doing, folks. It would take 2 hours and 12 minutes to radiate its own light the distance of its own diameter. Now, here's the bit where I added a little extra bit on. See that 1,710 that's in blue? Do we know what that is? 1,710. I'll tell you what that is. That is how many of our sun diameters fit into the sun. Sun diameter, blue, just make it different colour, but there are 1,710 my suns in UY Scuti's diameter. Mucho grande. Mucho grande. It's a very big star. That if they're telling us the truth, obviously. You just never can tell, can you? Got to be very careful. Right, so what we have here, we're only looking at the box, the red box, right? Everything else belongs to the absurdity of 8 minutes and 20 seconds travel time for light to get to us from the sun. Not to scale, but the distances in between. Look, there's the sun, and that's Saturn, Mercury, Venus, Earth, Mars, Jupiter, and Saturn, 1.4 billion kilometers away from the sun. If UY Scuti were our sun, it would come out to here. Right? At 2.377. If I quickly wanted to round it up, I'd say 2.4 billion. Right? 2.377. Quick round up. 2.4 billion. That means 1.2 here and 1.2 there. Our sun in the middle, you put UY Scuti, and it is going to span out from the center to nearly where Saturn is, and the same, obviously, that distance everywhere else. 2.4 billion kilometers, 2.377. So it would be like this. Right? This dish is not too far away from what UY Scuti would look like compared to the first 6 planets in our solar system. Right? Now, knowing this, one thing that doesn't change here and that is the speed of light. On. You're kidding me? Like, I thought that would just slip in there like that. Don't you dare. Alright. So now, UY Scuti is our sun. We're still 150 million kilometers away from it, but it's now UY Scuti. My sun has got a day off. Do you really think that if you had a star the size of UY Scuti 150 million kilometers away from you, and it was off, and you were facing it, you have a star with a diameter of 2.377 billion kilometers, and it's 150 million kilometers away from you, and it turns off, and it's just about to turn back on. Do you really think that if you were looking in its direction and it turned back on, that you would be oblivious, that you would not know, not notice it, because you're waiting for photons to arrive from the surface of UY Scuti, and it's going to take 8 minutes and 20 seconds to reach Earth. And then you'll go, yo, UY Scuti, you don't understand. Does it need saying? I don't think it needs saying. It is so ridiculous, right? It's the speed of light. Nothing, doesn't matter how big or small something is, does it? Light is just standard and travels 299,792 kilometers per second. To get to Earth, UY Scuti, if it was 150 million kilometers away, would be exactly the same as our sun, even though it's 1,710 times the diameter of our sun. There's something missing it's the common sense. But I'm not sure what it is people don't understand about what's happening right here, but do you think there's a delay in between that and the light source itself? It's purely because of a lack of common sense. I get that when you taught something it sticks, but with so many things, calling it out, you know what? Anyway, have a great, it's Australia Day today. Doesn't really do much for me. I always think some kind of celebration, it should be everybody, shouldn't it? Like governments have decided to teach children how to think instead of what to think. Then every single person on the planet, that would be a celebration. But conquering a country, taking it off of somebody else, celebration. I don't know, it's just the way I'm wired. All right, folks, listen, have a great rest of the day. And honestly, really, didn't want to waste the last minute and a bit. During the solar eclipse, when the sweet spot turns into a perfect moment, people find themselves watching, seeing the sun being blocked by the moon. It's all happening in real time. How do we know this? Well, because there is a distance from the light source to the thing being blocked, allegedly of 150 million kilometers. If it's a round or flat, listen, you know how that goes. And it's taking apparently 8 minutes for photons to get there, which are being blocked, but mysteriously, un misterio, el sol está detrás de la luna. Sun is behind the moon. And that cannot happen with a light delay of any amount of seconds. There is only one way for this to play out. And it is with absolute light. No delays. The only way those things could be lined up perfectly the way they are. All right, folks. Have a great rest of the day. 15 minutes. El sol. Light peeps.